Hi guys, welcome back to distance learning. We are now at week 5. I hope everybody is doing just fine. So for today's agenda, as always, we're going to do our usual reminders, the assignment overview, and also our interactive lesson, which means that you guys are just going to do your work as you watch my videos. So always take your attendance every single day. Flex hours are Mondays and Tuesdays. So Mondays, periods 1, 3, and 5, and Tuesdays, periods 4 and 6. Please join my live session the next day. That is how I can keep track of the ones that are still here and doing well. I just want to do a check-in with everybody. And also for me to recognize that you guys did come into my session, please just put in a simple hi on the chat. And also complete and turn in all of your assignments by Sunday, 11:59 p.m. Your assignment should look like this, the one that's been posted on Monday. What's different about this week's assignment is that you guys are supposed to be writing your answers on separate paper. And once you finish answering all of the questions, you are either going to take a picture of that and upload it on Google Classroom as an attachment, or you can scan it if you have a scanner at home. But whichever is easiest for you, the easiest is to take a picture using your cell phone and just uploading that picture as an attachment in your Google Classroom assignment. So it is calculations time, and you guys will be needing a calculator. So have your Google Doc assignment up, and you are going to follow along with how to do those problems. And as always, pause the video, rewind if there are parts where I went a little too fast or you just need me to repeat them. So that's the beauty of distance learning with these recorded lessons. You can go back. So we are doing the second part of Chapter 5.2 Solutions. Last week, as a review, you all remember that solutions is made up of 2 parts, solvents and solutes. And also certain factors that can affect how fast something can dissolve, the solubility. We've learned that the surface area and also temperature plays a part in how fast the solutes can dissolve. Now, this part of the chapter, we're going to learn all about concentrations and how to calculate them. Okay, so this catalyst question will be presented to you during the next time that I go back on my live sessions. What do you think it means when a solution is concentrated? So be ready to answer this catalyst question in the chat when I have my live session. This week's objective is for you guys to calculate solution concentrations and how the number of solute particles affect solution properties. 2 standards related to this: explanation for simple chemical reactions and also the effects of changing the temperature or concentration on the reaction rates. So with concentrations of solutions, what it means is how much of the solute is dissolved in a solvent. And if we take a look over here, this picture here represents high concentration and low concentration. The little red dots represent the solutes. So the figure on the left shows a high concentration relative to the figure on the right, low concentration. And you can see with the red dots, which represents the solutes. So if there are more solutes in a certain amount of solvent, it will be higher concentration. If the amount of solutes is a lot lower, then it will be lower concentration. And what is the purpose of studying concentrations? Well, first we need to know a certain amount of concentration for some substances because that can affect the speed of a chemical reaction. So the amount of solutes can actually affect the solution's properties. And also for manufacturers, creating the most effective and popular sports drinks. So the manufacturers of sports drinks, they take into account the electrolyte concentration in our bodies. So they want to make their sports drinks, the electrolyte concentration in sports drinks, to match closely with our body's electrolyte concentration. And also, if you were unfortunate enough to have this done to you in a hospital, doctors and nurses and other hospital technicians will also have to pay close attention to what type of solutions that they would hook you up to. These are called Ringer's solution, or just saline solution, and there is a specific concentration for these bags. For example, this one, there is a 0.9% sodium chloride. That is the ideal range, the amount of sodium chloride that would be injected into your body to replenish your fluids and also any ions you may have lost. So figuring out the correct concentration is really important for these things to be effective, for them to replenish your lost fluids and also ions. Now, we have to calculate the concentrations using molarity, molality, mass percent, volume percent, and parts per million. Okay? The molarity formula is represented by a big capital M, that is for molarity, and the formula for molarity is big M equals moles of solute divided by the liters of solution. And we're going to have to go back to the concept of moles. Remember that moles is a counting number. We know that a dozen means 12, pair means 2, a ream of paper is, I forget, 500 sheets? Yeah, possibly. A mole is 6.02 times 10 to the 23rd items. And it makes sense we're using moles because we are dealing with molecules, teeny tiny items. So with molarity, you're going to have to remember that we have to use moles. The solutes are the ones that are counted in moles. And the entire solution, which includes both solute and solvent, the entire solution will be measured in volume by the unit capital L for liter. Okay. And in order to do these problems, you're going to figure out what the known values are. You're going to plug in the known values in the formula and then solve for the unknown. And it's going to be simple math using multiplication and division. Please make it easier on yourself and get yourself a calculator to do these problems. Okay. Now the two problems that I will be going over together with you will be numbers 4 and 5, and the sixth one you will be doing yourself. Okay. So I don't want to have to do all of the writing on this PowerPoint slide. It's a bit difficult. So what I planned on doing is to write it out here. Okay, and let me make myself disappear so that we've got more room. All right. Okay, so the first one that we are going to do together, and let me make this a little bit bigger. There you go. Is number 4. What is the molarity of a solution made of 0.250 moles sodium chloride, NaCl, dissolved in H2O for a total of 3.61 liters of solution? Okay, so let me get my pen done. Okay, let's see. Is it writing? No, it's not. There you go. Pen. Okay, so the first thing that you want to do is to deconstruct this problem. You just gotta understand what this problem is saying. What is the molarity? What is the molarity? So this is your unknown. Okay, and let's do it this way. Let's figure out the known, K for known, and U for unknown. So our unknown, what is the molarity? Question mark. Molarity represented by capital M. Of a solution made of 0.250 moles of sodium chloride. Usually your case, the ones that are known are the ones with a numerical value. Okay, so we can write that down, 0.250 moles. Shorthand for mole is just MOL, just don't even bother putting the E, of sodium chloride. Okay, what else? Dissolved in H2O for a total of 3.61 liters of solution. Again, we have another known right here. So that's your other known, 3.61 liters of solution. And this is my shorthand for solution, SOLN. Okay. And next, I would want to put up the formula for molarity. The formula for molarity is capital M equals the moles of the solutes divided by the liters of the solution. All right. And let's take a look over here to figure out the big M, molarity. We need moles of solutes. Do we have the moles of solutes here? Well, it says 0.250 mole of NaCl. Let's read this again. 0.250 moles of NaCl dissolved in H2O. Well, if you guys remember the definition for solute, it's the item that is being dissolved. So this is the solute. Oopsie. What happened here? Let me erase it. Okay. So, there we go. Perfect. It doesn't have to move. Okay. Let me put the pen on again. Okay, so this is our solute. Okay, I see. I'm accidentally scrolling it up. And let's take a look. We've got the solution already, 3.61. So you just simply have to plug in the values. Okay, just plug in the values to figure out the big M. So it's 0.250 moles, okay, and that is the solute, the NaCl, divided by the liters of the solution, and we have it here, 3.61 liters of solution, okay, and for this one, you just need your handy dandy calculator. Have your calculator with you. Do I have mine? Is it working? I don't know. Okay, so on my calculator, 0.250 divided by 3.61 would equal to a whole lot of numbers. 0.06925278. Let's not put down all of those numbers, okay? We have 1, 2, 3 sig figs here. 1, 2, 3 sig figs here. The lowest amount of sig figs, 3 sig figs. Let's just reduce it to 3 sig figs. 0.0693. Okay, moles per liter. Okay, now this part here, the moles per liter, actually can be represented by big M. So you may want to rewrite that as 0.0693 big M for molarity. Moles per liter means molarity. And for short for molarity is molar. Sometimes you hear scientists just simply call it molar. So we have a 0.0693 molar solution. Okay, and I am going to stop the video here before we go on to the next one. So go ahead and take a small break before we move on.